Taaraaan Ganaraaation. I mean terrain generation. The thing responsible for beautiful landscapes, astonishing views, and endless exploration. And then there is my world.
A flat brick. But what if there's a way to fix this? Huh? What is that? Onion, chicken, eggs, milk. What is that? Perlin noise? That's right.
We can use perlin noise to fix this. But what is perlin noise, I hear you ask? No worries, I got you covered. I made a quick example here for you. Shit. Alright, here's the example. Okay, here's the example. Makes no sense, right? Someone could say it's quite noisy. Anyways, you can see we got white and black pixels that fade between each other. These colors represent different heights. The darker the color is, the lower the height, and the brighter the color is, the higher the height. I think. If it's not the other way around. Anyways, we can use this to generate the terrain. But obviously, one cannot go from a brick to a landscape. No. So, we will be following along the Reinventing Minecraft World Generation by Henrik Kniberg video. And eventually, we'll get there. Now, the first logical thing you could do to try to make an epic terrain is just put blocks randomly everywhere. Which is exactly what we'll be doing. And blam! Would not exactly call this an improvement. But at least it is not flat anymore. Then what we can do is to use the sane function to get a more wavy terrain. So now we will go from this to... well damn. We are apparently trying to render chunks that do not exist. But we can fix this by asking if there are any blocks inside of the chunk before we try to render it. And boom! Look at those sexy waves. Now let's make those sexy waves thick. Yo! Look at that! But yeah, we can go even further by adding a second sine function. And boom! Now this is Taaraaan. Now, let's add water. But there's a slight problem. We don't have any water textures. So let's put our trusted grass texture there instead. It looks like poo. We got epic poo water! Woo! Okay, but silliness aside, let's get silly. Let's do the actual perlin noise now. And hypothetically, we could get this from an already existing library. Or we could make our own perlin noise, which is exactly what we will do. No. First, we'll figure out which coordinate we are on. Then we'll do an and-bit operation on the permutation table. Wow, that is crazy. Anyways, here's the shitty noise we just created. But don't you worry guys, I know how to make this noise cool. We can add dirt and grass, and if it works, it will look pretty cool. It does work, but it doesn't look cool. Or so I thought. But we can fix this by using something called octaves. Octaves are basically perlin noise on perlin noise. So let's apply it into our world and bam! Now this is pretty damn cool and all, but we can make it even cooler by making the world rendering dynamic. But for that, we'll need to create a world class to keep track of all of the chunks, because otherwise this will get messy. Well, it's already messy, but you know. And once we have created the world class, instead of generating the world directly, we will just comment this out and leave it there just in case, like any sane programmer would do. Then what we will do is to create this function, which will take in the player position and generate all the nearby chunks. Yo, what the f***? So yeah, everything is okay as long as I go in the positive X and Z direction. But as soon as I go to the negative, we get this. Okay, So the only logical solution to this is obviously to put absolute values on everything. And bada bing bada boom, what the f. So yeah, I was rounding minus 0.5 to 0 instead of minus 1. And a second problem I had was this. Normally, a program should crash here. But no, my program be like, oh, we Gucci man, and gives you some garbage value to just work with, like what the f. But anyways, now the dynamic world generation works. But keeping all of these chunks rendered in the world is not good for performance. So let's filter out chunks that are not close to the player. And this is how we will do it. We will create two containers. One containing the chunks that should be rendered, and another one containing the chunks that are loaded but not seen. And just like that. Yo!
Yes! It works now. Please change the render distance. Oh.
Yeah, so I was trying to do something very illegal stuff, like incrementing the end iterator. If you do not know what that means, don't worry, it's just illegal. But yeah, after serving my time in iterator jail, we finally got the dynamic unloading working. Alright, let's try it with 32 chunks render distance. Oh wow, look at that frame rate.
Oh my god.
Oh hell. Oh fuck, it just flipped. Oh yes, the performance, I love it. No, this performance is pretty bad. But we can increase it by excluding chunks that are not seen by the camera. And according to ChatGPT, you can use something called frustum culling, which is So according to me, we can just cast a ray out from the center of each chunk, and then we can see if it's within a specific angle from the camera. And if it is, we will add it to the render container. So, let's start out by creating a function called Cac-ulate. I can't spell.
I mean,
it kind of works.
Yeah, let's tweak the perspective a bit and it should look better. Oh wow, amazing! Wrong way! Alright, fixed it. But yeah, it's a pretty solid improvement from 400 frames per second to 1200 just by ignoring chunks that should not be seen. But now that we have dynamic chunk rendering, let's get back to the terrain generation and improve on it.
wow, look at that!
Okay.
Yes.
I think something's wrong.
You think? I think it's perfect. Like, I love it.
Here are the Irish lands, Irish circle walls with a death sentence. Alright, I think our perlin noise is cool and all, but maybe it's just time to get the real deal. So, let's get this fast noise light by Auburn. Thanks Auburn, very cool. And after setting everything up, we get one pointy block. Wow. Okay, after a bit of tweaking some values, we have some pretty damn cool looking terrain. Now, we can still take this even a step further by doing some continentalness, which I will explain in another video because, yeah, stay tuned. But here we go.
Wow, look at that. Continent. That's cool.
I like this peak. Alright, so now with the decent looking terrain, I think it's time to get rid of that black background. We can do that by implementing a skybox. In order to implement a skybox, it's quite simple. All we need is 2 more shaders, a few more textures, a whole new pipeline, and God's blessing. That's not too much to ask for.
I was pretty sure that would have fixed it. And then I don't even need these ones. Why? Alright, so now if I compile this, I should have no problems. Fuck, I have problems. Oh wow, look at that. That's not good. Come on, baby, come on. I know it will work. Okay, fuck. Oh, I think I might just look at this tomorrow morning.
And then, after many hours and nights, I finally got it. Oh, no way, it's there. It's fucked, but it's there. Oh my god. I mean, who wouldn't be that happy after seeing a messed up image on their screen? Some might say that is some intense looking weather. Like, just imagine waking up one day and there's like a pink dude just staring down like, how are you doing? Alright, that is it for this video. Don't forget to hit the subscribe button and enjoy the Ribbit Moon while you're at it. Nothing better to look at than the beautiful Ribbit Moon. Alright, see ya. Bye.